One Michael Unger here with another edition of Ask an Astronomer here on a beautiful sunny day, as you can see behind me and our astronomers' heads, and that is the other just two doors down from me is Marley, our astronomer. How is the sun treating you, Marley?
This is blinding, but I'm happy it's still here for now.
We can be thankful for some things here, and we're reaching the midpoint of a really exciting month. We've got the opera that's taken over our planetarium. We've got a special event next month where we're going to be doing a cosmic night around humans in space, talking about the mental health effects of long-term duration of astronauts in space. But for this episode of Ask an Astronomer, we are going to delve into some of the latest news on asteroids. So we got a couple mission updates and a couple fun stuff to get into. If you are out there watching on YouTube or Facebook and want to get in on the conversation, if you have a question, if it's even beyond just asteroids, anything under the universe, throw it into the chat. We will answer it before we get to the half-hour mark. But let's get into it, Marley. Asteroids, what's happening out there?
So much has been happening. We've been not able to talk about them for a while. There's been a couple big mission updates. One very recently actually was on November 1st. So the Lucy spacecraft. So Lucy is a spacecraft that is on its way to investigate targets in the Jupiter Trojan asteroids. And these asteroids are actually two groups of asteroids. You know, we think of most of them being in that asteroid belt between Mars and Jupiter, but there's these two groups. We call them offhand just the Trojans. We are usually referring to the Jupiter Trojan asteroids, but Mars and Earth also have some Trojan asteroids as well. And they get their name because they're asteroids that share an orbit with a planet. So these Jupiter Trojan asteroids are in Jupiter's orbit, but they're located at these very special gravity balance points, the Lagrangian points, right? So you might be more familiar with the L2 Lagrange point, right, where the James Webb Space Telescope makes its home. There's other ones, you know, throughout orbits. And so the asteroids, the Trojan asteroids, make their homes at the L4 and the L5 Lagrangian points, which are the ones just above, like in front of and behind a planet, in this case, Jupiter. There's about 5,000 of these asteroids in Jupiter's orbit, and about 65% of them are in the leading group, what they're called, L4, and the other 35% are in the trailing group or following group at L5. And scientists are pretty sure these types of asteroids are likely to be made up of remnants of the same, early solar system material that went on to form Jupiter, Saturn, Uranus, and Neptune, those outer planets in our solar system. And so they act as these time capsules from that period of time, which is about 4 billion years ago. So they're really interesting to study. They're just kind of difficult to get to. They're kind of sprawling around. They follow Jupiter. And so getting to them was, took a lot of time and took a lot of science in building the spacecraft. And what we found, in studying the Trojans is that they have different surface compositions from each other. So they're not entirely similar, but they're not entirely different. But what it means is that they probably formed in different places in the solar system and then moved to their current areas as our solar system evolved and changed and everything got settled into those places. So the purpose of Lucy is to study these asteroids and trying to learn what that diversity between the groups and between the members of the groups tells us about the history of our own planets, particularly the outer solar system, what was happening over there. It's got a bunch of different destinations it'll fly to. This image is actually part of it showing its flight path and highlighting the specific objects it'll be looking at. The green circle is Earth, just to give us a benchmark, and the orangey one is where Jupiter is.
Very
It'll
cool.
study, yeah, Lucy's going to study surface geology, surface color and composition, learning relative ages of the asteroids in these groups, trying to determine, distribution of minerals, ice, and organic species if they're there, determining mass and density, and even looking for satellites and rings around the Trojan asteroids, just looking for any fun features. And these are the targets. So there's a couple of them. Some have been added as the mission lengths have gone on. The first one that just passed on November 1st that Lucy just flew by was Dinkinesh on November 1st, 2023, and a couple others to follow well into 2033. So it's a very long mission. It takes a very long time to, get enough speed and be in the right place at the right time to be able to observe these targets.
So of course, if we're talking about, some of these asteroids that before we visited them, did we not have much information about them? Like when they chose these targets, were they choosing them because of their location and their size? What did we know about these asteroids before we arrived at them?
Not much, right? Which is kind of
Yeah,
why we were able to view them, right, with different telescopes and different things that we have on Earth and, in different spacecraft that have flown by, but not a lot of information at all. And so these ones are picked, there's a couple factors that go into it, but largely because they're kind of the easier ones to get to. I know the asteroid belt and like asteroid, even the Trojans, when they're shown like in a diagram, they all look like really, really close together and it's really packed. There's actually a lot of empty space between them, and they're quite distant from each other once you're in that general area. So they were kind of picked on interest, but also can we even get to them in the first place?
right. Well, if we're going to fly by, and as you said a couple of weeks ago, we flew by Dinkinesh. Do we have any pictures from that flyby?
We do. And what was fun is that Dinkinesh is actually two. It's actually two
Oh,
asteroids.
okay.
So very similar to the Didymos system. There's a larger
Wait,
asteroid
are
and then
those
a moon.
attached?
No, they're not attached. They
Okay.
just look like they're attached. Right. I thought it was attached too, but they're not. It's called a moonrise. They're calling this image where the satellite is
Okay.
emerging from behind the main asteroid. So they haven't named the satellite asteroid yet, or the moonlit asteroid, whatever you want to call it. I'm pretty sure the main asteroid will remain being called Dinkinesh because that's what we've been calling it before we knew there were two of them. But so far it's Dinkinesh and unnamed satellite is what they're being called.
Do we know
Uh,
what Dinkinesh is named for?
it's Arabic for marvelous, I think, is the
Okay.
name. Yeah. I'm pretty sure if I'm remembering what I read correctly. But leading up to the flyby, the team was wondering if it was a binary because, Lucy's got all these different instruments on it. It's got different scientific equipment. It's studying things as it's approaching these objects. And the brightness was changing with time in a really interesting and weird way. And so scientists, as they were getting closer and closer to the asteroid, were wondering if it was a binary pair. And then they got this image and it was, shown that it is indeed a binary system. The larger body, so the larger asteroid, kind of, I guess, in the foreground, is about 790 meters across at its widest point, and the smaller satellite asteroid is about 220 meters. And the whole point of adding Dinkinesh to the flight roster, it wasn't one of the initial ones, was it wanted to be able to test the tracking system, right? So Lucy has to know where it is in space. It has to be able to track and keep its cameras pointed on the object as it moves past it. And it's moving past these objects at like 16,000 kilometers per hour. So this little spacecraft is moving quite quickly,
Hmm.
and they need a system that's able to keep up with that speed and track appropriately. So this was a test, and it did work quite well. We get this excellent image out of it, and actually a series of images that I didn't include because they animated it in an interesting way, but very fun to look at if you go to the Lucy website. Scientists have already noticed that there's some similarities to the Didymos and Dimorphos system, but there's also a lot of differences that they're going to be investigating as time goes on. One of those differences being the satellite is actually a contact binary. So the satellite
Hmm.
itself is actually two that have fused together on contact, which is very, very
Wow.
cool. In the first image, the lobes of the contact binary are like behind each other. So we're like looking down
Right.
it. And then as Lucy moved past the system, we now see the actual formation of that little satellite moonlit asteroid. Very different perspective.
Yeah.
Contact binaries aren't uncommon, but we haven't seen a lot of them up close, and we've never seen one orbiting another asteroid. So this is very interesting and a fun weird mystery for scientists to look at and try to figure out.
Yeah, the last time that I think I remember seeing contact binary was that trans-Neptunian object that New Horizons flew by. The what was it called?
Oh, it
The
was it Arakoth? Yeah, that's got
Aircraft?
yeah. It looks like a snowman, right?
Yeah.
That's a contact binary. We see them. They're just never like in this way. Like this is weird.
Yeah, very cool. And I just looked it up, Dinkinesh Amharic, which is the Ethiopian name for the human ancestor fossil Lucy, which is what the mission is named
Oh,
after.
well, what's the one? Okay, maybe one of the other ones I mixed it up with. But that's cool. Yeah. It's yeah, Lucy. It's the era when we still named things people names. I think we're gonna see that less and less.
Well, and Lucy's not named after an actual person named Lucy, you
No,
know.
no, that's true. But I think we're still gonna. That's gonna stop being a thing. I think, unless it's an acronym.
Has there been any I Love Lucy memes that are coming out here? What's
I couldn't find any, and I wish there were some. I that show's good, but there's a lot of Lucy in the Sky with Diamonds
okay?
esque
Yeah.
things coming out from this mission, but which is fine. That's a good song, I guess.
All right, so we got Dinkinesh, and
Hmm.
we've got more targets that Lucy's going to be heading towards, but of course we have to wait until 2025.
Yeah.
It's wild, like the timelines of these missions. We have to wait so long.
Well, I think to get to the next one, it's actually got to go back around Earth and go back over.
Okay.
Like it's quite complicated, the flight trajectory they've laid out. But it's I don't know, it hit the first target on time and passed it successfully. So here's hoping for the rest of them.
Okay, so we'll leave Lucy and we'll actually, just like Lucy, come back to Earth for another mission that has returned to Earth, and that is OSIRIS-REx,
Yes.
looking like a literal UFO there in the middle of the desert. What are the updates with that amazing mission?
Well, we haven't been able to talk about this one in a hot second because we've had, guests on and all these different, but there's been so many developments with the OSIRIS-REx mission. It got back September 24th, landing in Utah's Great Salt Lake Desert, right? It looks this way, black and charred, because it was on fire as it came through the atmosphere. That was one of the best questions, I think, that was asked from a student at the press conference on October 11th that they had. A student asked, like, why is it all black now? And it was like, oh, it was on fire, But great question, because when it was first built, it was white. So once it landed, it was transported to a temporary clean room once it got back to Earth. This to understand the updates with OSIRIS-REx, we also have to understand like what I'll be talking about. There's a lot of different structures that are involved. So what was in that image that I just showed is, the entire return capsule, right? So
Mhm.
you have the heat shield, you have the back shell, parachute housing that's long gone because it landed, but this is all the stuff that was blackened in that image. And then you have what's inside the return capsule. So inside you have the canister lid, you have the sample head, that's that green thing. You have this thing called the avionics deck, the canister latch, different thermal shells, and also a capture mechanism. And then inside here where the sample head is the actual tag SAM. So that's where the actual sample is located from that touch and go maneuver they did, where they, bounced off the asteroid and, pulled up a bunch of debris and material from the surface of asteroid Bennu.
Mhm.
So keep this in mind because I'm going to be using these words. I have another diagram, but this is to help understand what comes later.
Okay.
So after it was landed, it was removed from the desert. It was flown across. It was actually taken to Houston eventually, where it now lives. The Lockheed Martin recovery specialists removed the lid off of the sample return canister. So they took the whole lid off, right? So now we just have the sample return canister itself. And they found dark powder and sand-sized particles on the avionics deck. So this little gray thing. They found a bunch of asteroid material just
Oh,
sitting
wow.
on the avionics deck when it was removed. And that canister got delivered to Houston on September 25th. And they have a whole new lab designed specifically for the OSIRIS-REx mission. So it's like this, they call it the glove box. And it's this, container that's sealed off from the atmosphere here inside of a clean room. That's why everyone's all masked up and in the gowns and everything. And they put their hands into the gloves and the gloves stay inside. It's a whole thing to keep the sample as pristine as possible. So here's another look with the sample lid open. You can see some residual dust. That's asteroid material there. They saw particles slowly escaping before it was stowed away when the touch and go maneuver first happened on the asteroid. So scientists
Mhm.
weren't surprised to find, debris in floating and amongst the actual lid. But there was just a lot more than they thought there was going to be. And so it took a very long time to collect all of it, which is why, even though it was opened and moved to Houston on the 25th, we didn't have this press conference until the 11th of October. They were collecting a bunch of material, not even from the proper material container itself. And they provided a very quick sample analysis and they found that there was evidence of carbon and water in that initial analysis. They wanted to get 60 grams of asteroid material. When they opened that science canister lid, they found so much that it got them pretty close to that 60 grams just from material left over. So this is an outside view of the OSIRIS-REx sample collector. You can see this is a bunch of debris. Here's zoomed in stereoscopic images. Apparently, okay, if you relax your eyes, it makes it look like it's coming out of the screen. I've never been able to successfully do that. I just don't think my eyes can relax. But if you can, it looks very cool, according to Brian May.
Well, keep in mind, Brian May comes from a different era where he was probably exposed to a lot of let's say mind-altering substances that would help him maybe see that sort of stuff.
Yeah, it works. I don't know. They have machines that do this now, so I've never been able to do it, but it's very cool. They say to look through the screen as if you're looking into infinity, which I think is just zone out a little and then it'll pop out, but not sure. But this is the material that's found on top of the Tag SAM. So the actual Tag SAM container is like, this is the kind of roof, I guess, of it. And then you have all this debris sitting on top of it. So this is each boulder in this image is actually only a centimeter across. And so they found quite a lot of bits of this asteroid, forever away. And they actually ended up collecting 70.3 grams of rocks and dust and material from the asteroid. That's including the stuff on the avionics deck. That's including the stuff on top of the Tag SAM and a little bit from actually inside the Tag SAM itself. But the thing about that is that they haven't actually been able to get all of the material out of the Tag SAM because they can't get into it. So this brings back this diagram. This blue ring that you're seeing in this image is this part in the picture on the right-hand side. There are 35 fasteners that kind of keep the Tag SAM closed, and 2 of them cannot be opened with the tools that were approved and put into the glove box. So they can't open it. Oops, indeed. They have been working on this. The last update was like late October-ish, and they're still working on trying to open it. What they were able to do, this gray thing is a Mylar flap. And so what they did is they were able to push down on the Mylar flap and pull out material using tweezers and a scoop to try to get some of it, which is what pushed them to that 70-gram marker. But they still can't open the rest of it. There's still quite a lot of material in there that we can't get to because something happened and 2 of them won't work. And I guess they don't want to damage the sample, right? I was like, why don't they just rip the lid off? Like, it's 2 screws, but also it's NASA, so it's probably incredibly strong screws. And also they don't want to ruin the sample at all. So that's where we stand with OSIRIS-REx, is that they hit their benchmark, but there's still more and we can't get to it because of 2 little tiny fasteners.
Right. I can imagine that there's probably like that one engineer that's in there that's so fed up with bureaucracy and it's just like, I can just rip it off, I'll just wait until after hours and I'll get in there and then like everyone will arrive the next day and like, it's open. This is a miracle. And like, I was like, yeah, just rip it off.
Who could have had, like the thing, like in this glove box, right? They can't, it's a sterile environment inside of a sterile environment. Like they're taking so much precautions to make sure that this remains, scientifically sterile and all of that. And so I did laugh a lot though when I read that they can't open it, because it is kind of funny, but it is very, very frustrating. They're very lucky that they were able to still reach their 60-gram threshold by, just the fact that the asteroid, was more bouldery than we thought it was. Like we didn't realize it was had so much loose material on the surface of it, and it's the fact that it did, and that loose material was still in the surrounding area when the lid closed, that they were able to get it right. So it is very big sigh of relief, but also how did these 2 fasteners get so stuck and why aren't they working?
Yeah, I guess was surprising to me, that's probably maybe surprising to the scientists, that when you look at that image of what's even on top of the canister, like it's literal like dirt, right? Like it's as if that you're walking on like a gravel field. But you wouldn't expect that from such a small world, right? Like you'd think like, those smaller pieces, they just like float off into space. Like it really is a rubble pile, It's very confusing to think like, like how that happens. So like obviously like lots and lots of impacts, over time, just like smashing into each other and then just creating these smaller chunks, and then they just sit there forever. Like how long have those tiny little chunks been in that form? It's very cool to think about.
It is very cool. And that's like part of the overall OSIRIS-REx mission as well. Like not only, trying to use it as a time capsule for Earth and using it to understand, how Earth has gone through changes in the times of the solar system, but also understanding just like what was going on. Like how did this asteroid form? Why is it still the way that it is? And, did something similar happen here on our own planet, right? Like trying to put together the puzzle pieces of early solar system formation using this rock, this pile of rubble really that who knows what's gone on with it, and still surprises us like to this day, even what we found inside of that sample, like carbon and water. Like we knew there'd be carbon in it. It's that just the type of asteroid it is. They typically have lots of carbon, but the water that they found, is always very exciting. In their press conference on October 11th, one of the scientists described it as like an astrobiologist's dream. Like the amounts of carbon and the amounts of water was exciting to the astrobiologists, which means there's a lot more there that still needs to be studied.
Yeah, very cool. And of course, this is probably going to take, like, the time frame on this is probably going to be a while, because like they're still still studying moon rocks. I mean, like the samples that we're getting, probably going to be like a lifetime's worth of study here.
Oh, easily. Yeah. Especially because we can't get into the crust.
Is it going to really take that long, I think?
Well, I don't know. Like, I don't know what they'll end up doing. They're still trying. I don't know if they can put anything new into the glove box now that the sample's in there, right? Like, I don't know what that process would look like. But, with moon rocks, some of the stuff we took, we just never looked at because we knew that the technology would get better. Right. So there are moon rocks from the Apollo era, like the Apollo 17, that were only recently looked at like a few years ago, because we had the technology to be able to uncover what we wanted to know. And so it's very possible that, some of the material, it's being distributed amongst different institutions and different scientists. Like Canada gets some, Canadian researchers at UBC actually get some of the sample. But I'm sure there's some of it that's just being kept, until we have the better technology to be able to do it. And maybe it'll be better technology that can open two fasteners on a canister lid and they can use the rest of the sample. But I'm sure that it's not going to be done all overnight, right? It's going to be paced out and used in different ways.
Yeah, very, very cool. Well, awesome. Well, thank you, Marley. This has been a great update on two different asteroid missions. And we know that there's more to come still on OSIRIS-REx, so hopefully we can have a little bit more of an update. And as you said, there's that local connection. And at some point, we certainly want to bring in maybe some of Katherine Johnson's team that did work on the OSIRIS-REx mission. And we'll do a night in the next few years here at the Space Center. If you're out there watching, we've got a few more minutes. If you want to get in on some questions on anything that Marley's presented on in this episode, throw them into the chat, or of course, like any questions that you have under the universe. We've only got a couple more Ask an Astronomer episodes before the end of the year, Marley. We've got one coming up in a couple of weeks on November the 30th, and then our final episode of the year is going to be on December the 14th. We will do a year in review of this wonderful year 2023 and all of the crazy things that happen in space. That's going to lead up to, of course, we're going to again do perihelion. If you've been with us for the last couple of years, we use perihelion, that point of when the Earth is at its closest to the sun as our astronomers' New Year's. We use that as a jumping off point for 2024. So that is going to be on January 2nd, but that's going to be an in-person presentation. So you're going to have to come here for our final time slot in the planetarium at 4 p.m. on January the 2nd to help celebrate perihelion with us. But you certainly want to join us for those last couple of episodes for this year. Marley, thank you so much for this presentation. For all of you watching, we will see you again in a couple weeks. Take care.